All right, guys, I'd like to first congratulate you on the steps towards becoming rocket scientists. But no jokes aside, this isn't rocket science. I'm going to give you guys a demonstration of what we're doing quick, just in case you guys are a little bit spooked. So what we got here is what we're going to make. It's one of our rockets. If I ignite the end, oh, that one blew. Let me try again.
It blew.
That wasn't very
Don't
rapid
try it
at all.
at home, children.
Okay, this is like the one we're going to be making.
Okay, Travis. 10, 9.
And there she goes. I don't know if you guys seen that shoot. It happens pretty fast.
Just like 4th of July.
But that's what we're doing. So if you guys are a little bit concerned with fire, it doesn't get too hot. It's just one match. You could shoot outside, but matches go away pretty quick. You're going to have a bit of a smell. I just wanted to give you guys a heads up on that before we start.
Where's some earplugs?
And we got our packages here. So we're going to start by opening up our packages, guys.
Okay, Sean.
I don't know if you guys got the memo, but you will need a pair of scissors, and it's just to cut this and one other part. So please get out your scissors, get them ready. You got a whole box of matches. You're only gonna need one match. So just a single match at this point
I can't do it.
to make your rockets. You guys wanna see me fire off another rocket quick?
Yes, please, Sean.
You do, Barbara? Should I fire another rocket so that maybe they can see it better?
Should I catch it?
No, you cannot do that.
Okay, let's see if I can get it in the shot better.
Come on. 10, 9, 8, 7.
Last one, I got one more demo. I'm just gonna fire it off because I have 4 demos. I just wanted to make sure
Come on,
I didn't have any issues with one of them.
It's like Canada Day.
Okay, last one, watch it fire. I'll fire it. You guys see it?
Right there.
So,
Don't hit me, please.
yeah, they're pretty cool. Cool little rockets,
Look,
eh?
it went over there.
Okay, everybody's got their stuff out. You got your scissors.
Smoking everywhere.
Okay, I want you to grab your matchstick. I want you to put it on your square piece of tinfoil. First off, if your tinfoil is wrinkly like Barbara's over there, I need you guys to smooth out the tinfoil. So just lay it on the table, smooth it out. Smooth out your tinfoil, make sure it's smooth, because it could have got crinkled in transportation a bit. If it's a little bit wrinkly, it smooths out just fine. You're gonna take your match. You're gonna cut off the head of your match. So you're left with, can this one see me? Is this?
Yeah.
So you're left with the head of your match and the body of your match.
Travis, you're gonna have to hold it lower so this one can see.
I'll move it there. I just want to make sure these
Okay.
guys see it. So you're cutting off the head of your match. You're keeping both parts, just the head. And you can see that.
Oh, perfect, right there. Yeah.
So you got the head of the match, and you got the body of the match. Now you guys, in your packages, you got a strip of sandpaper,
Yeah.
right? Everybody's got sandpaper. You're gonna take your stick end, your little stick that you cut away from the head, put your head to the side, keep it safe, we're gonna need that. You're gonna take your sandpaper and you're gonna make this stick smooth with it. So you just roll it in the sandpaper and get it nice and smooth and round. So there's not very much
I don't
friction.
want to do that.
on your
I
stick.
don't want to do that. I don't want to
Just make sure it's smooth and a little bit thinner than it was.
Good, Travis. Steve, look at this. Just like Canada Day, Steve.
So use your sandpaper, work at the stick. I'm just smoothing it out in here. You can rub it in there. So you guys got a whole box of matches. If you have tinfoil at home, you guys can really make make and continue this experiment on your own once you get the basic idea of it. But we've had some pretty good launches around here. So we've had some fun. I've been trying to fire them at Steve when he falls asleep. Every time he falls asleep, I fire a rocket at him.
Very cool.
Same with Jer.
Fire on me, you catch fire.
Steve can't handle the heat, right, guys? What? Are you gonna participate then, Jer, or did you want to make one? No. Thought you were gonna make one.
I do it at home.
You're gonna do it at home.
Oh, yeah.
Now's the perfect time to do it, though, because you got me here to help you. You got a question. Is there any questions at this time, guys? Everyone's working on their sticks, smoothing them out. Give you a few minutes to... Once you got one smooth stick, though, all you have to do is cut off the heads of the matches, and you can reuse the stick. If you guys got a piece of metal, just make sure it's not too thin of a fit. You kind of want the fit to be smooth and tight.
Made in China.
Oh dear. Are you scared of stuff made in China or what?
Keep away from children. Why?
Guys, Barbara has a question. Why should we keep matches away from children?
Because you're going to burn the house down.
Because they're gonna burn the house down, right?
Please don't kill
Or burn themselves, or who knows?
Yes, it's always lock them away.
Yeah, fire's not the safest thing in the world. Shoot, in my mailbox I got rocket facts. Oh no.
This is always like good cupboards. You never can tell. Children can go in the...
Sorry guys, I have some rocket facts. Karen's gonna go grab those for me because I want to, while we're doing these rockets, I'd like to teach you about real rockets and just a little bit more about how crazy rocket science really is, you know?
Just like,
Because these are toy rockets, but could you imagine it's not a very easy thing to get off the ground, such a big, heavy object when you have gravity on the Earth. So you have to have a lot of power to get yourself off this planet. I think that they use rockets to do that, so.
rocket trucks.
Down the house with trousers. Just kidding. Here you go.
Thank you, Karen.
Ooh,
Okay, so as you guys know, NASA is a space agency. Everybody probably knows where NASA is or about
In
NASA.
the States.
That's right. So since NASA fired their first rocket about 50 years ago or so, they've launched 500 rockets into outer space since.
Oh my God, up in the sky.
500 rockets, yeah.
In the moon. Mm-hmm. Not going to moon.
NASA's biggest rocket is called the Saturn V rocket. That's the rocket that was used to go to the moon and for all the Apollo missions. So as you guys can see, let me go back. The Saturn V rocket, what's cool is it has two different fuel sources. It has liquid fuel and a solid fuel. And it'll burn both to get off this planet. Our little rockets today are not liquid fuel. This is a solid fuel. You see how it's a solid?
Yes.
And we're using that as our propellant today for our rocket. Okay, is everybody good? You got your stick sanded? Everybody's...
No, I can't do it.
You can't do it.
No.
Okay, guys, so you're gonna measure out with your tin foil. See if you can, I don't know if you guys can see
Help me,
it.
please. Karen, help me.
Maybe I'll cut it first and I'll show you the size.
Here, Karen, how are you going to cut it, Karen?
You wanna cut the tin foil just slightly bigger, like lengthwise than your matchstick.
Yes.
You're gonna cut a square. You can see it's like slightly bigger than my matchstick, or the stick I just
Thank you. Don't
just
cut your
formed.
fingers.
Everyone sees that, I hope.
Don't. Karen, please
The
don't.
step after that, we're gonna grab our tin foil again. I'm just gonna wait for the scissors here for a sec.
Thank you.
And we're gonna cut another square nick out of that square. So it looks like, kind of like a big L. Do you see that, guys? It's like a big L.
Yeah.
So it's like an L. Okay, what I like to do here, we'll use this one, is I like to start my roll. So I'll put my, I don't know if YouTube, how much YouTube can see. It's kind of hard for me when I can't see myself. I'm gonna have my L shape there. And I'm gonna have this like that. And I am gonna roll the tinfoil just a little bit. I'm not gonna continue to roll it. This just makes it easier to assemble if you put a roll like that. Slowly roll. So now you got a little bit of a curved roll. Do you see that, guys? Okay, you're gonna see how this, where I started that roll, there's gonna be
Boy,
a thicker side, right? You're gonna take the head of your match and you're gonna put it about in the middle of that L. So it's sitting somewhere, I hope you guys can see this. Can you see the match head?
yes, I see it.
So it's sitting about halfway in there. Not too close to the end. That's very important. Do not roll it too close to the end.
Okay, thank you.
Okay, now you're gonna put the stick in with it, but they're not attached, right? And you're gonna roll this up.
Yeah.
The way you roll, cut off the head, twist the head. If there's a hole in the head, that could wreck the rocket. Did you see that first rocket, or was it the first or second rocket I fired there, guys? Did you see how it kind of blew up out of the head?
Yeah.
That's why we put that extra little bit at the tip, because, well, let me get into some rocket facts, and you'll kind of understand, even with a little rocket, the same principles have to be at play. So in order for a rocket to break the gravity of Earth, like I was saying earlier, it's very hard to get off Earth. A rocket has to travel at 7 miles a second. Now, I'm not really a scientist, but 7 miles a second sounds very, very fast. 7 miles a second, that's insane. Like, could you imagine something going 7 miles a second, guys? That's well over 1,000 kilometers an hour. Jeez, anyway, that's a real fact, by the way. That's 7 miles a second to escape Earth's gravity, which is, I've never personally, in real life, I have not seen anything go so fast. I've only heard of things going so fast. Which brings me to a little bit of an unrelated question. Did you guys know if you were driving in a convertible going faster than the speed of sound, you could not hear yourself talk or the person beside you? You would leave your voice behind. You'd be traveling faster than your voice, meaning nothing would come out. Just thought that would be funny to tell you guys. Okay.
But people behind you could hear. They'd be like, where's that
Okay, so
voice coming from?
rocket technology really started up in World War II. The first rocket designed, or the first people to make a rocket, was actually the Germans.
Yes.
And they used that rocket for warfare. They didn't use it for space. They used it against the Britons, and they used it against there was another place they used it against. Belgium. So Britain and Belgium were attacked by the first rockets that were made by Germans. The rocket was called a V2 rocket. So the V2 rocket was the first rocket developed.
Allison has a question.
Yes, Allison, what is it?
Unmute yourself there. Ali,
Allison,
unmute yourself. Thank you. Okay, what is your question? Go ahead.
Can you do it again, Travis?
Oh, yeah, for sure, Al. We have enough supplies to make a few, as you can see. So just make sure once you get it in, that it's, for those who are caught up, that this is fitting nice and smooth, that it feels smooth coming off your stick. Okay, that it's smooth along your stick.
Yeah, where do you put it? On the L part of the? I don't know.
Here, I'm gonna whip up another one right now, guys.
Do this one.
Do this one.
Okay, now you're
So
gonna
you
watch
should
this.
sand this down to what?
Just sand it down
So it's not
round and,
splintery?
yeah,
Okay, thank
smooth. It has to be smooth. Okay, so our first step was
Steve?
to cut a square out of our tin foil, about the length, just a little bit bigger than the match that we had, the small matches we have. You're gonna grab a match, number 2, step 2, and you're gonna cut the head off that match and put it to the side. We're keeping that head. That's gonna be our fuel source for our rocket. You're then gonna take the shaft or the stick that remains. You're gonna have your sandpaper and you're gonna smooth out this stick into a nice round, smooth surface. It doesn't necessarily have to be round, but round will create less friction when that rocket takes off. If you have any friction, because it's such a light thing, if that tin foil catches on anything, your rocket won't go anywhere. But as you can see, if it's smooth enough, I think my rocket probably traveled about 12, 15 feet there. So they can shoot. I think we shot one off the other day. And the thing, we couldn't even tell how far it would have went, because it went flying to the roof at like faster than we could even see.
Another rocket.
It really took off. It was pretty
I don't know
cool.
what just turned on.
That's
I had it turned way down low.
Well,
Oh, that's
you have
okay.
to call me,
So any more questions? Does that make sense, guys, those steps? It takes a little bit of time to smooth out that stick. So I'll have you work on that. Okay, so the space race. I'm going to talk about the space race. The people who started the space race, do you know what country they were from? Can anybody guess? Does anybody have that answer? Who started the space race? Who proposed to put the first satellite out in space and use rockets to do it? That's what I'm asking.
United States,
No, it was not the United States.
Russia.
Correct, it was Russia. Russia was the first to propose a plan to the Soviet government to deploy an artificial satellite to orbit the Earth.
Sputnik.
Yeah, it was called the Sputnik or something like that. I think, yeah, I forget the guys' names. I didn't write that down. I didn't think you guys would
Russia, Sean, Russia.
retain it anyways. But, the United States was the first place to put a man on the moon, apparently, so they say. And they used the Saturn V rocket for that, which I brought up earlier. And the Saturn V rocket is 111 meters tall, and it uses 1.2 million liters of liquid oxygen to combust and create 7.5 million pounds of thrust to launch itself and escape Earth's gravity. So 7.5 million pounds of thrust. Isn't that insane, guys?
Super.
Well, that's a lot of pressure. So you can kind of understand when a rocket takes off, especially in the early years, it would take off and what would happen? Boom, it would explode, right? And the reason that was is because it had so much force behind it, so many little things could go wrong. All the parts in that rocket had to withstand that force or it would, explode. And it'd be a very violent explosion when you have 1.2 million liters of combustible fuel in there, you know? So a pretty scary explosion it can create. Okay, so does anybody have any questions?
No.
Okay, once you got your stick smoothed out, I'll show you the next part here. You're gonna cut a little notch into your tin foil here and make it into an L shape with the notch. So just into an L shape like so.
Jamie's,
You guys can see that. It's an L shape.
they're going
Uh-oh.
to pick up Jamie. There too.
And now what I like to do is I like to start my roll off, otherwise it's hard to roll up.
Steve,
So I'll roll just a bit, just to get it started. I'll roll it under itself, and then I'll roll it back. So you have a little bit of a cup, as you can see in there. There's a lip, that's the word for it. There's a lip. You're gonna take the head of your match head. You're gonna put it in the middle the middle of that L, the tall part of that L shape. It needs just like that rocket I was talking about with the, now we have nowhere near the amount of force a Saturn V rocket has, obviously, because we're using match heads. But it's still because it's gonna combust and explode in here, you still need to reinforce that, and that's what that L shape's for. And you also cut out this nick because you could go the whole way with that, but then you're adding a lot of weight to your rocket, and you don't want a lot of weight on your rocket. The lighter the object, the better. Which is actually brings me into my next space fact that I wanted to share with you guys. Oh shoot. Yeah, sorry, I'll share that in just a sec, but you're gonna put the stick in with it, butt it up so they're touching, and then you're gonna roll the rocket up.
A little bit lower, Trey. Perfect, yeah.
I'm having a bit of a technical difficulty here. Yeah, just roll your rocket up in that tin foil and close off the head very tightly. Closing off the head of your rocket is very important because if you
Which
do not,
side, Travis?
sorry?
Which side?
Which side?
Match head go.
Does the match head go?
Which,
Okay, I'll show you again. I'll give you a visual.
can't see.
Okay, so the match head right here. Can you guys see that? You got your L shape, right? You're gonna have a longer part, and the match is gonna go this way in there. Sorry, get it ready. So the match is gonna be in there like this, but the head is gonna be cut off, right?
Yeah.
And then the match is gonna go on this longer side. It's gonna roll up into the rocket.
So
which side?
which way does the match head face?
The match head is facing out, like, so this is the top of the rocket, you guys can see?
Yeah.
It's in the middle and it's facing out that way. This is the shaft of the rocket.
I missed that again because your hand thing, Valley.
This part here would be the tip of the rocket. This is the base of the rocket, like the shaft part. Does that make sense now?
Does it make
We
sense?
still don't know which way that match head faces.
This way.
It almost doesn't matter. You can put that,
Where's
as
the
long as
back
it's
of the L?
detached inside, it should combust, like. So right now,
Faces this way then.
this is the rocket we just completed. The match head is loose up in this top, right at the very, very top of it. Or right in here. And then this is all hollow. The stick just slides off and on.
My face is this way though then. Towards the wall. Towards the wall though then.
Well, let me give it a test. Let's see if this one fires off.
Okay.
So I'll light it off just like I have it for you guys, but if you want to strike a match, that works too. Oop. So I'll strike a match. If you guys want to light your rockets, and you just kind of get it up in the tip.
10, 9, 8. 4, 3, 2, 1. No good sign.
And it didn't fire
Oh,
off.
it didn't work. Oh, brother.
Sorry guys, we have the air conditioner on right now. It keeps pulling out my flame and moving it around really bad.
Oh, brother. Outside's better to do outside.
It was working really well when it was off, but firing them off, nothing. There, that's a nicer flame.
Just like
I
the-
can't see if
just
they
like
can
the fire
see.
was last
They
night.
can.
Wow, that one's a real painful
That
one.
one, why would they show?
Are you gonna launch?
No.
What is going
It's
on?
like the movie Failure to Launch.
Gonna burn
What
it.
is happening? Okay, guys, this should have fired already. Wow,
Oh!
that
Okay.
was quite the delay. So as you can see, that one's still.
That scared me, guys.
That kind of startled me. I was like, it's a dud. It's not working, and there it goes.
Not working. No.
It's kind of perfect because we had Canada Day yesterday, and fireworks are like rockets, right? They use like They put it in caps and they wrap those caps in. And then there's different parts. So a firework would explode in sequence. So it would explode one part and then another part and then another part. It's really kind of cool how it releases. But that's kind of like rocket
Can I take it
technology
home,
too, or
Lucas?
similar to very basic what we're doing here.
You don't need to.
Any questions, guys, so far?
What one with it, mine?
We're gonna cut yours and make a.
Let's see if I can get it across the screen. I wish we had like a slow-mo.
Can I wear the scissors if you are using them?
This one's called.
7 minutes and 46 seconds. This is crumply.
Did it go on the screen? Could you see it go across or no? Was it too high? Oh.
10 more minutes?
Almost shot Sean with the rocket, guys. It was pretty nice. I was hoping you guys could see it on screen, but it's kind of a low angle, so when the rocket goes the other way, it's kind of tricky to catch them. They also move very, very fast.
Is this too wrinkly to work?
Nope, just smooth it out a bit.
Okay.
It'll work.
Okay, thank you, my turn now.
Yeah, so any questions, guys? Allison, you're okay there? Working? It's working for you now? You guys figured it out?
We don't want you guys making any life-size rockets after this though.
Okay, so guys, as you know, NASA's kind of fallen behind. There's a new space company out called SpaceX.
Yeah.
SpaceX has developed the first reusable rocket called a Falcon 9 rocket. The Falcon, the thing about rockets is they cost billions of dollars a lot of the time. And up to now, they have not been reusable. So they use this thing and then they toss it away and they use a few parts maybe, or they launch into space and never comes back. Whatever the deal is with those things. They make a lot of waste and they waste a lot of resource, a lot of money.
I forgot to
SpaceX has developed a rocket that can fire off, let loose whatever it's carrying, and then come back down to Earth and land itself safely without destroying the rocket. And all it needs to be done to it is refuel. So that is awesome.
Thank you.
So the Falcon 9 was the first, like the start. Sorry? Is there somebody who needs help there? Or?
I know, it's just Joanne, I'm the first.
So the Falcon 9 was the first step to just kind of getting rockets reusable. They then made a rocket that not only rivals the Saturn V rocket though, it beats it in almost every way. It's called the Falcon Heavy rocket, and they'll use 2 Falcon 9s on the side and a really big Falcon Heavy rocket. And this Falcon Heavy rocket can launch 119,000 pounds, or 57 metric tons it can carry into space. So it can carry very, very large objects into space, or a lot of tools into space. With its test object, they flew a car and released a car into space. They got a mannequin and they put a mannequin in a spacesuit, a NASA spacesuit, or I think it was a NASA spacesuit or something, and they called him Spaceman, and he's up in space floating around in a car right now. I think they have a few tools in the car, but not very many. And he just thought it would be funny. It was a cheap way when I guess, cheaper than for them to just build a probe or something, I guess. Okay, and the Falcon Heavy can generate 5 million pounds of force, equal to 18 Boeing jets, or Boeing 747s. You know the big Boeing 747s?
Yes.
It has more power than 18 of them, but all in one engine. So if a Boeing vehicle had the power of a Falcon Heavy, it would not be able to fly because it wouldn't be able to handle the strain of that force. So that's why rockets are designed the way they are. A plane cannot handle that force. And the Falcon Heavy's main goal is they're planning, the first one is they're going to stop at the moon. After that, they're planning on going to Mars and actually bringing astronauts or people to Mars. So, as you guys know, I was saying earlier that rockets have a lot of, they're dangerous. They can blow up, and a lot of astronauts have tried to go to space and they've blown up in the process, just trying to escape Earth's atmosphere.
Yes, they're blown up.
And back in the day, once a rocket went, there's probably a 0% chance of survival. There's no way you're escaping it. If an astronaut's rocket was to blow up, done. Those astronauts are not going to make it back to Earth. But now with the Falcon Heavy rocket, they actually put enough safety protocols in that there's a high success rate of survival for the astronauts. So there's sensors all over the rocket. If something goes wrong, those astronauts are, I guess, launched in their little patty thing, or they got like a little thing that launches off the thing and escapes the rocket from before they blow up.
Escape pod.
An escape pod, exactly. In space, not so lucky. There's still no escape pod for space that I know of that they've brought up. So if it explodes in space, you're probably gonna deflate or explode.
Or implode.
I think you explode in space.
You explode.
Or maybe no, you're right, you would implode. It'd be like a vacuum chamber. So if you put something into a vacuum chamber, space is a vacuum, guys. If I put a balloon in a vacuum chamber, all the oxygen in that balloon would go like this and get sucked out or wrinkle down. And that's the same thing that would happen to our human bodies. We would just go in space. We cannot handle it. We're so used to gravity that our bodies are constantly fighting against gravity. Our muscles are always working against gravity, and so you take that gravity away and you put us in a vacuum in space, and we'll just squish upon ourselves. Implode, I think is what it's called. That's pretty scary.
Then you just become a hot dog.
Okay, so has anybody got their rocket done yet? And do they have any questions? Okay, roll it up, Karen. Fire it.
I don't know where's this roll is this way, and where does the match go?
Start it here, and you're gonna roll it that way.
Wait, start this one here?
Yep.
And the match head?
So again, I'm gonna go over it again, guys. You're gonna cut this tin foil into a square of some kind. You're gonna cut a notch out of it, make it into an L shape. Okay, so you make your tin foil into an L shape, just as a recap, in case you guys missed it. You're gonna take your match. You're gonna cut off the head of your match. You're gonna smooth out the rest of that shaft of the match with your sandpaper. Once you get that smoothed out, I like to start a lip or a roll on the very end with the tin foil. So you put the match in the tin foil and you give it a little roll until it rolls underneath itself, and then you unroll it. You remove that match stick for a sec. You'll put it back in just a sec. I like to put the head. You're placing the head of the match facing that way and about middle of that L or that lengthy part. And you're gonna stick that, whatever match or whatever you're firing with, back in against the head of the match. Kind of get in the secure place.
Can you see?
So it's in there like that. Let's see if you guys, so it's in there like this. Then you're gonna I have it facing me because it makes it easier for me to roll it. Or that's the way I like to do it. Everyone has their preferences. And you're just gonna roll it up. It doesn't have to be too tight, because remember you want it to escape. You don't want it too loose or you're gonna get no power when it launches. So you still want it tight, but you want it smooth so it can escape the stick. See how it's very smoothly escaping my stick? That's exactly how you want it. But you don't want it too loose. If it's too loose, all your power is gonna come around the stick and your rocket's just gonna go boop. So the more tight or less space you have between your ignition source and along the shaft. Okay, we got 1 minute, guys. The less space you have between your shaft and the ignition source will create more power or more force, just like basic physics. And then you just light the tip of just at the tip where you have it reinforced with metal or tin foil, you put the heat. You leave the heat there until it ignites inside, which shouldn't take too long. And there she goes.
Ooh, that was a good one.
Man, that went across the room. I don't even know where that went.
Okay.
Over there.
But that's about as good as it gets, that one I just fired off that I whipped up real quick.
Mine now?
Oh yeah, so guys, that went like 20 feet.
Oh, you wonder how.
That was a good one.
Down. Mine, Travis, no? Mine, before I go home? Mine now, where's mine?
But you can kind of see how that smoke is at the top. So at the top you have the match, right guys? And that when this combusts, or the top of the match combusts, all that force is pulled down through the shaft, creating a, what's the word for it? Propulsion?
Propulsion.
I don't know if that's even the right word for it, but it creates force, or it creates pressure.
Can't do that.
Pressure along the shaft.
Bye-bye.
That's it.
See you in two, see you.
So hopefully they got it. I didn't see anybody fire off a rocket.
I didn't
but-
get,